Okay, this video covers the Hydronics Circuit Simulator, which is one of the most powerful modules within the Hydronics Design Studio 3.0. As you can see, there's a graphical representation of the circuits in parallel, as well as you have the typical pull-downs that we have in most of the modules that take care of the manufacturer's circulators, both the standard as well as the multi-mode, different types of fluids, as well as different pipe sizes. Here we go, starting out from the start screen in the Hydronics Design Studio 3.0, and we'll go over to third icon over, which is the Hydronic Circuit Simulator. We'll pick that, and we'll get into the basic interface of the Hydronic Circuit Simulator. And you can see you have basically one circuit here, and we can add multiple branch circuits by just clicking 2, 3, 4. It does go up to 12 circuits in parallel, and you can adjust each one of those and spec out the specifications for them. I'll bring this back down to 3 branch circuits, and we'll talk about some of the detail of the interface. Typically the blue background is the outputs or the results here. Now the results is throughout the graphical interface, as you'll see in a second. We can also have different interface tools, resistance values, and here it's showing the resistance of each of the circuits as well as the overall circuit. I'll also show you the balance valves, and here these balance valves will give you an adjustment on each one of these circuits and give you the CV value for each one of those adjustments, so you can adjust how many gallons per minute you want going through that particular circuit to try to balance it out. You notice there are warnings that come up depending on your system and your circulator that you pick. This is a typical interface for the circulators that I've shown in some of the other modules, as well as you can go over to the multi-mode circulators. I'll go back again, and you can see I've got a little warning here. It's probably because I got too much resistance. I'll open that up a little bit, and the warning goes. I can also define header piping. Again, I threw headers in there now, and I'm giving a warning again. Probably flow rate's a little bit too low. Each one of these headers can be defined. You can see I've got 100 feet in there. Let me bring it down to 12 feet. Accept that. Let me go down to 12 feet here, because it has a default of 100. Let me go down to 12. Accept. 12. Accept. Okay, and you can see the warning went away because I reduced the resistances of the header circuits. I can also go in and define each one of these circuits, how much tubing we have, elbows, valves, and all that. Let's say I have 3 gate valves. I'll accept that. And you can see that the flow rate changed. I can go back into this one, maybe reduce the amount of piping. Accept that. Okay, again, the flow rate changed here. Other features, you can turn off any circuit with the press of a button here, and now all the circuits are off. I'll turn it back on again. You can also change the type of fluid, as in all the modules that have fluid calculations in it. We can also set up a bypass valve, and we can call it manufacturer specs on the bypass valves, not a valid threshold pressure for this particular valve. So you do have warnings come up for bypass valves, as well as setting the threshold pressure for that valve. A little bit more about the outputs. We have the system flow rate, head added, and differential pressure in PSI. We have the total system heat output. Now you can see that's 0 because I haven't defined any heat output. If I go into one of these modules and I say, okay, I've got fin tube baseboard, and I can set how many feet I've got. Let's say I've got 33 feet of a baseboard, and this is the output of that baseboard. I will accept that, and as you can see now, I have 10,400 BTUs in this particular circuit. Let me turn off the bypass valve. And see, I did not load any heat onto these two circuits, but I could go in there. I could put radiant floor in there. It's only certain size piping that I can use within radiant floor, so there's another warning. I'd like to get into a little bit more detail on defining the heat emitters. If we go to, let's say, the third one over here, and we say we want radiant floor, and you can see I've got 5/8 PEX tubing, so that's okay. If I had picked a different, let's say we go back to copper or something, and you can see it gives me that error I talked about earlier. I'll hit OK, and I'll go back to the PEX. And now, if I accept this, right? If I accept this, it's saying I'm going to be using radiant floor, this particular type of tubing, a database here of different type spacing of the tubing, and I'll hit accept and return. That heat goes into this particular branch of the circuit. If I go back to that and I say, well, let me copy that into all these circuits. So let's say they're all that way. So I'll hit copy, and then it says, do you really want to copy? And I say yes. And then it tells me I could still cancel this copy if I wanted to, or I can accept it by hitting the accept and return. So I hit OK, and I'll hit accept and return. Now, as you can see, the heat output of that radiant is the same, and if I go into that particular one, you can see it's the same selection, it's the same everything in terms of copying over from that original one. Now, if I want to go and change this particular one, I can change that, hit accept, and again, now they're going to be different. This is a 4-inch. This one here is the 1.5 inch, which I just changed, and then this one here is still the 4-inch. And you can see they have different outputs. I wanted to show you the total capability of this system with all 12 circuits in parallel. I can also define any of the headers, as well as I can show you the balance valves and also output the resistances everywhere in the system. It also gives you the total resistance here. As you can see from the flow rates here, the flow rates get reduced as you go out farther in the system because these header piping is getting more and more and more. If you go into any one of these, you can see you've got a default of 100 feet of tubing. That allows you to go in there and change that, but that's why as you set up these circuits, more and more circuits, the flow reduces as you go along here. Now, you can go in and change any of those, but if you think the piping in between the headers here is very small, you can just negate the headers, and you can see now that the flow rates are all the same. The reason the flow rates are all the same is because in each one of these piping, they're all the same. Again, this is the default that we're using. So as I reduce the number of branch circuits, we'll watch this flow rate, overall flow rate, that should go down. So as you can see, the flow rates, as I reduce as I reduce the number of circuits, this overall system flow rate goes down. And the reason why it goes down is because now we're trying to put all that flow rate through smaller and smaller cross sections of pipe, and the flow rate goes down, and of course the pressure goes up. So for a final example here, I'll show, let's say we've got 3 circuits and I have these balancing valves on it, and let's say I wanted to balance it relative, and I could look at the heat output and maybe try to balance the heat output in all 3 of these. Try to knock that one down, try to knock that down a little bit, maybe bring this up a little. I guess no, that's about it. So there is some balancing you can do to try to balance the heat. I think that about concludes our talk on the Hydronics Circuit Simulator, which again is one of the modules within Hydronics Design Studio 3.0. Thank you.